What's going on, guys? Welcome back to Classic Octane. I am Taylor. So today is going to be a Will It Run video, but it's not going to be on a car or a motorcycle. It's going to be on my lathe. So the short story behind this lathe, if you're not familiar, is roughly a year and a half ago, Alan from Revival Cycles here in Austin bought a couple of machines. This is kind of the worst one of the bunch, and kind of paid it forward and gave it to me for free. So I got the lathe for free in the exact condition you see it now. Missing a decent amount of parts and pieces, but still a very heavy duty, very good quality machine. So what I need to do today, I'm finally getting around to it, is give this thing a full health check. I want to get the motor up and running with a variable frequency drive, run it through the gears, run all of our feeds and everything, and just kind of make sure the lathe is in good salvageable condition for someone like me. If it is, then I can move on to the next step of the process of, buying a chuck, buying a bunch of tooling, a tailstock. There's a bunch of things we need to get to make this an actual functional tool. But I don't want to invest any more money into it until I know that the kind of base lathe is a good, usable condition. So that's going to be the name of the game today. First step is to see if we can get this motor running. I wanted to start off with, as quick as possible, an overview of the lathe itself and its current condition. So this is a Colchester closing 15-inch lathe, which means I can do a piece of work 15 inches in diameter. This does have what's called a gap bed, which means I can remove this section right here and do a piece of work that I think is 24, maybe even as big as 28 inches in diameter. So it's a big lathe with a ton of capacity. The total bed length is 48 inches. So this is what's referred to as a 1548. This particular model was sometime in the mid-1960s, something like that. This is what they call a Mark 1.5 round head lathe, if you want to look that up. Most of these lathes are known under the Colchester brand in England. So it's like the Colchester Student, Colchester Master, and then something else. So this is, I think, what's called the Teacher or the Master, which is the bigger of the two. Okay. Most of this lathe is going to be set up to do imperial cutting. So unfortunately, I do not have any built-in metric thread cutting abilities. But if I'm not mistaken, we can get some different change gears and kind of change the ratio of the threading gearbox to cut metric threads, should I end up doing that in the future. The overall condition is pretty good. It's all covered in a very thick layer of grease and oil, which has kept everything from rusting, but it is going to be a bit of a pain to clean. 2 out of 3 of the wheels over here check out good, and one of them doesn't. So what I mean by that is, I think this is called the cross slide. Nice, smooth operation, goes back and forth. I don't feel any binding, anything like that. There's not a ton of backlash. It's exactly what I would hope for. Same with the cross slide, and I may get these terms mixed up, but this moves back and forth very nicely. All of the readings and everything, all of the dials are nice and clean. So those two, fully operational, no big deal. One that is a cause for concern is this big guy here. So there is a huge amount of movement in this hand wheel. Some of that may be just the wheel itself being loose, but my gut is it's actually the rack and pinion setup in here to move this whole thing back and forth. It's just really worn out. So that may be a project we have to address in the future, of replacing some of that kind of rack and pinion system, get rid of a lot of that backlash. I haven't actually gone in here and looked at anything, so I don't know if any of that's adjustable or something's just loose, but it moves nice and free, but it does have a ton of play. This machine does also have power feed and 2 axes, so I can have it feed across the work here, or I can have it feed kind of back towards the wall to be able to do like facing cuts and that kind of stuff as well. So what this lever and this button are for, to kind of change those 2 directions. It also came with a cool threading attachment, so instead of having to watch a threading dial, I can simply set this to the thread that I want, hold this lever down, and when the lead screw gets in the correct position, this will automatically click down into place. It will feed across, thread our part, and then we can either set up an automatic stop or just stop it manually. So I look forward to kind of learn how to do all of that single point threading, but that's the general overview of the lathe itself. Let's take you to the back side, show you the motor, and show you what we're working with to get that VFD hooked up. So I have the lathe pulled away from the wall and all of the side covers and everything off so we can gain access to the components we need. So really quickly, this is the rotary switch. So this is factory what they use to switch between forward and reverse, high speed, low speed, all of that stuff is controlled through here. I might decide to kind of repurpose this switch to control our variable frequency drive in the future, just so I can retain those kind of factory levers on the front. I may just decide to run it all from kind of more modern buttons on a little control panel and just kind of forget about this old stuff completely. And there's some pros and cons and stuff. We'll worry about that at a later date. This whole middle box I no longer need because it is the 3-phase kind of input motor controller that's not going to work for our variable frequency drive. Down here is our absolutely ginormous 5 horsepower 3-phase motor. So this is a 2-speed motor, as I mentioned, so 5 horsepower in high speed, 2.5 horsepower in low speed. I've decided with this particular application that I am just going to permanently wire it in high speed mode, and I can just vary like that frequency from 60 hertz down to 30 hertz, and that will give us exactly the same functionality as high and low speed on this. So I'm not going to have to worry about switching wiring and having different coils and all that kind of stuff. It is literally just going to be controlling the frequency. Best I can tell from searching on the internet for a couple of hours over the last week or so, that's how most people run these setups. Some people, will run it in low speed and double the frequency. I kind of like the idea of having the frequency. The only potential problem is I think we'll have more torque down low than we would before. So we'll just have to be aware of that. It could, in theory, have additional wear on the gear train. This thing is built like an absolute tank. I'm not going to be doing any kind of crazy heavy cuts at low RPMs. This lathe is going to live the rest of its life pretty easy in my shop. So that's the way we're going to wire it up. I still need to determine kind of how those connections are going to be made, and we'll cover that in just a minute. Let me show you the variable frequency drive I got to run this bad boy. So this is the variable frequency drive I'm going to be running. Very, very similar to the unit I have on my do-all bandsaw. Biggest difference is just the capacity. So you want to upsize your variable frequency drive. They are measured in amperage as well as kind of horsepower that they're rated for. If you're like me and you're going from single to 3-phase, you want a VFD that's rated for higher than what your motor is rated for. So my particular motor on the little plate on the motor says 14 amps is about the max. This is 28, maybe even 30 amps is what it's rated for. So I wanted to have more than enough capacity so we're not running this thing at kind of full duty cycle and have the potential to kind of overheat this thing or run into any crazy issues or anything like that. So this particular one should be more than enough for what we need. For today's video, I'm going to do the absolute bare minimum of connecting it, and it's going to be basically single phase input and then 3-phase output to our motor. I'm not going to worry about any of these additional inputs and outputs. This is for a later date when we hook up our control panel with start and stop switches and an external potentiometer and all that kind of stuff we can worry about later on. We don't need to do that today. We're just trying to make sure that this lathe is going to work for us and is going to work at all. I have not seen this thing under power. So let's get this thing hooked up and see how she does. Just hooked up the VFD and I figured I'd run you guys through how I did it. So we have our single phase power running in. We have our two black and white lines going to the R and the T on the input. Then we have our green, which is our ground. Then we have 3 wires coming out of the VFD and the, UVW. So UVW are running to our motor. So if you remember, there are 9 wires that are coming out of here because it is that 2-speed motor. The little motor plate shows high speed, we connect 1, 2, and 3 together. So that's what I have down here is T1, 2, and 3 just connected together. A little bit of electrical tape on there. And then what's left is T4, 5, and 6. So what I've done is just take it from the UVW output and go U to number 4, V to number 5, W to number 6. So that's what we have wired up right here. And again, everything is just kind of temporarily run through, electrical taped. None of this is a permanent install. So in theory, that should be the minimum wiring required to get this thing going. For our VFD, there are a couple of settings you need to go through when you first fire up the VFD before you even try and send any power to the motor itself. All of this is of course covered in the manual. Basically, we just need to set our kind of starting frequency, the frequency of our motor itself, and maximum, minimum frequencies, all that kind of stuff, what it's expecting to see, how we want to control things, whether we're going to be using the potentiometer to control the frequency, we're going to be using the buttons. There's a million different settings, but you just kind of have to set it up for whatever particular motor you're running. So I have it just set right now to use this factory control panel, and then I just spin this little knob, and those numbers changing are, of course, our frequencies. So for our test run of the motor, we're gonna start somewhere real low, maybe around, let's call it, 15 hertz-ish, which is gonna be, a quarter of our normal speed. But before I do that, I actually need to top the machine up with some oil because most of it has since leaked out. So I'm gonna go ahead and pull this top cover off. I'll show you guys what it looks like under there, and we'll throw in some, I think I got some ISO 32, something like that. The oil that is recommended to run in this machine has been discontinued for years. So I basically bought the modern equivalent. So let me pull this top plate off. I can show you guys what the gears look like, and then we'll top this up with some oil, and we'll top our bottom gearbox with some oil as well. Got my big 5-gallon bucket of oil, just filled up the bottom gearbox. You can see all the little gears in here. Everything actually looks to be in really good shape. Nothing looks crazy worn, everything moves nice and free. So fill that up to where the oil is right in the middle of that sight glass. Now we're moving on to the top. So here's our entire gear train, if you want to call it that. That gives us all of our different speeds. So basically the speeds are adjusted by these two knobs and then this knob right here. So as you move these knobs, not unlike a transmission, it just kind of engages and disengages different gears and gives you different ratios. So sometimes you gotta kind of spin the spindle a little bit just to get them kind of meshed together, but the combination of these three levers gives you that all the way from 37 up to 1500 RPMs, as well as the two speeds of the motor. So pretty cool how it all works, but I'm very happy with the condition of everything in here, because obviously if one of these gears or any of these gears were heavily worn, something like that, they can of course be replaced. But that's just going to very much kind of overcomplicate this project. So for what I'm looking for, this all seems great. I'm going to go ahead and fill this up with oil until it's halfway up our sight glass, and then we're ready to turn this thing on for the first time and see if it actually works. We're ready to go here. So I have it set up for what should be 37 RPMs at low speed, so at 30 hertz. So that should keep everything moving nice and slow as we go through and kind of test everything. Full disclosure, I tried to start it a minute ago and I was just getting a click. After some troubleshooting, I realized that the parameters for start speed and also stop speed were not set to what they were supposed to be set to from default. So the manual said it was supposed to be on like 10-second ramp up and ramp down. It was at 0.1 seconds. So it was trying to start the motor to full speed in 0.1 seconds, and there's just too much weight and inertia. So I changed it to 5 seconds ramp up and 5 seconds ramp down. So I'm just going to set us at, let's call it 15 hertz to start. Let's go. Going smoothly. No crazy noise in the motor, no crazy noise in the bearings, at least at this speed. Nice. Alright, let's bump it up to 30 hertz. Okay, that's 30. that should officially be 37 RPMs. Not bad. We'll carry it up to 60 hertz, which will then put us at 75 RPMs. A little bit more noise, but it's still very quiet. Our feed rod, I don't remember what that's called, is spinning as it should, but our lead screw isn't because we don't have it engaged right now. Let's go ahead and test out some feeds. Okay. Seems to be feeding nice and slow. Kind of set right in the middle, so I wouldn't expect it to be much faster than that, but cross-side seems to be feeding well. Let's see how this does. Moving yet? Yeah, it's moving. It's a little bit notchy. See how it's like kind of stopping, starting again? That's kind of unfortunate. That's probably the same parts that are worn out when we do it manually that are causing that. I don't know if that's something that's adjustable or not. Yeah, so it's kind of stopped right now. That's not ideal. That's something we'll have to look at. Let's shut it down and gauge our lead screw and see how the threading does. Nice slow ramp down. Seemed to do well. So that should be this lever here. All right, that should be engaged. We can fire it back up. Still running at that same 60 hertz. Okay, so now I should be able to hold this lever down. And then when the lead screw is in the right spot, it should engage and feed. Okay. So this should be 23 threads per inch is what that speed is. See, that feeds much better than the whatever normal power feed is, because that's just latching onto that lead screw, which isn't, apparently is worn out, so. Disengage, pull back from our thread, come back to the beginning, dial it in, go back to 0. Yeah, threading should work well. The only thing I'm concerned about now is that. Overall, I am very pleased with the results we got today. So I'm going to kind of split this up into two sections. The left side of the lathe, arguably the most complex and important part, everything works flawless. I mean, all of the gears seem to shift really smoothly. The motor just fired right up and, you know, runs nice and smooth. The VFD works really well. Once we got those start and stop times figured out, and the VFD wasn't fighting against the inertia of the machine itself, you know, it works perfect. I haven't had any other faults or anything pop up. So I'm extremely pleased with this side of the lathe. This section, a little bit disappointed. So we obviously knew there was going to be some issues just with the amount of play we have in this hand wheel. Unfortunately, it does look like that issue affects our power feed as well. It seemed very notchy. It did not seem happy. It was moving and there was no grinding or anything crazy, but it just seemed like there was a lot of slop, and it just is not going to result in good surface finishes or anything like that, because as this thing kind of shifts along, as you're cutting a piece of metal, the point of a power feed is to have a nice, smooth, consistent feed of the tool across the work, which leaves a nice finish. If it's kind of juddering and bouncing back and forth, that's no better than us doing it by hand. So that's a bit unfortunate. It does look like that also kind of plagues our cross feed as well. And I don't know if that's something that's worn out in the power feed or if that's just the machine itself. Maybe both of these parts are worn out. I don't know yet. But since the kind of biggest portion of the lathe has checked out well, that gives me the confidence to go ahead and dive into this, you know, invest some money where needed to replace some worn out parts. And we did exactly what we wanted to do today of kind of, okay, we checked the boxes of this lathe is a lathe that's worth bringing back to life. Now we move on to the next step to see, you know, just how big of a project that's going to be. Well, that's all I have time for in this video, guys. I hope you enjoyed watching me get the old lathe up and running. I'm really excited to get this tool kind of set up in the shop and usable. Between the lathe and the mill, I mean, we should be able to make just about anything we need, which is really exciting. So I'm going to start to do some research on what parts and pieces we need. If you happen to be an expert or have any amount of knowledge in lathes and you have an idea of where I should start, please do leave a comment below. I am open to any and all suggestions. So I appreciate you guys watching. Stay tuned to part 3 and 4 and who knows how many videos I'm going to end up putting together on this thing. We have a good amount of work ahead of us, but I'm excited to do it. So I appreciate you guys watching, and I'll see you on the next one.